Hi, grade 8 students. Today's lesson is involving a couple of different concepts. One is finding the area of squares that are arranged inside of a grid. And you'll notice this square happens to be churned slightly, so that makes it a little bit difficult to find its area. Additionally, we're going to take a look at something called Pythagorean triples. Your lesson is pretty short in size. It's not a whole lot of problems, so let's get started. This first shape right here, at first glance, when you think about finding areas of something, usually when they're squares, the area is pretty easy to find. If I draw a shape like this, you might say that the area is 4 square units. How did I figure that out? Well, if I divide this into sections based on the grid and the dots that appear here, we have 4 different squares, each 1 unit in size, so we call it 4 square units. But how do we figure out the area of something like this, where, as I said earlier, the shape is kind of churned or angled? Well, here's a thought. Let's start by using a different colored pen, and let's figure out at least a portion of it first of all. This part right here that I am enclosing in the color purple, I hope the purple shows up, I'm not sure it will, but hopefully it will, is how big? Well, if you look, it's 4 sections high and 4 sections wide, so we could say that this part of it is 16 square units. I think I'm going to switch over to the different color because I'm not sure that's showing up. 16 square units. But we still have these sections here, 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 and here. How would we figure that out? Well, watch what I'm about to do. Carefully, please. You'll notice I'm creating a rather long rectangle. And this rectangle is 1, 2, 3, 4, 5 units in size. 5 units in size. You'll also notice that there's a diagonal going through that rectangle. If I shade this portion of it, I have shaded half of that rectangle, or half of the 5 square units. In other words, this shaded part is 2.5 square units. Let's continue that same process going all the way around this shape. We're going to create another rectangle right here, and we're going to think the same way we did before. We're going to think about shading just this portion of it. And again, because the large rectangle has an area of 5 square units, and this is half of that large rectangle, we have another 2.5 square units. We could do the same thing with this portion of it, 2.5 square units. And finally, we can do the same thing with this portion right here. Uh-oh, there goes my grid. But I think we're in the home stretch. 2.5 square units again. So, if I try to get the screen to come back on again, there we go. So what do we have? We have the 16 square units plus 4 groups of 2.5 square units that make up that original shape that we were talking about before. So we write 16 plus 4 times 2.5, and that should be our total area. 4 times 2.5 is 10. So the area of this entire square is 26 square units. Hopefully that'll help you for that first page in today's lesson of day 4 on page 458. But what about Pythagorean triples? What are Pythagorean triples? Pythagorean triples are 3 numbers that when you use them as the lengths of a triangle will create for you a right triangle. How can you tell whether or not three numbers are a Pythagorean triple? Well, here's one way. Take a look at this set of numbers right here and ask yourself which one of them is the biggest number. Obviously, it's the 14. I'm going to switch away from purple again. Now, remember from last year and the year before, the Pythagorean theorem. A squared plus b squared equals c squared. We're going to stick that 14 right here. We're going to stick the 12 right here and the 9 right here. What is 9 squared? 81. 12 squared is 144. And 14 squared is 196. Does this plus this equal this? Well, let's see. Uh-oh. No, they do not equal. They do not equal. Therefore, these numbers, we would have to say no, these numbers are not a Pythagorean triple. Now let's take a look at this set of numbers. 15 is the largest one, so we put 15 squared equaling 12 squared plus 9 squared, because we're following the formula of a squared plus b squared equals c squared, the Pythagorean theorem. We've got 81 plus 144, which we already said is equal to 225. 15 squared is, oh, hey, this is a Pythagorean triple, because when you use the Pythagorean theorem, you get the left side being equal to the right side. This is the kind of work you'll want to do for problem 6 on page 459. Okay, grade 8, hopefully you can get your way through this lesson for today. This is day 4, pages 458 and 459. And again, if you get stuck, please give me a call at 517-242-3138. Thank you.